Hello viewers, welcome to MS Pathashala. In today's video, we will explore one of the most important concepts in computer number system conversions. We will cover the theory behind converting between decimal, binary, octal and hexadecimal number systems. Let's start our today topic, decimal to binary number system conversions. First of all, we understand theory, how to convert decimal to binary number system. So to convert decimal number to binary, we divide the number by 2 repeatedly and write down the remainders. Then finally we read the remainders in reverse order. Then after we take an example decimal to binary number system conversion. We have 56 base 10 and this number converted into binary number. So divided by 2, then repeatedly divided and write down the remainders. This is the remainders, okay, this is the remainders numbers. And then after we write down from bottom to top or reverse order, we also called as a reverse order. So we easily checked our answer, this is correct or not, we can easily checked, okay. So 1 2 4 8 16 32 64 128, like this order. Then after we put our numbers from bottom to top, I means reverse order. So we put here, and where is 1 we edit and 0 is as it is, okay. So 32 plus 16 plus 8 is equal to 56. So 56 is converted into binary number 111000 base 2. This is our answer. We easily convert into decimal number into binary number. So another example, we are also clear from that example is called to what it means, mm, convert decimal number into binary number. So first of all we write here solution, then after we divide it by 2. So 64 to the 128, so remainder, this is remainder, so we put here, so remainder, this is remainder. We put it there. Then 2 32 the 32 into 2 also 64, so there is remainder 0. 16 into 2, there is a remainder also 0, so we put here. So 8 to the 16, so there is also remainder 0, so we put here. Then after we from when there is 8 last, we write from bottom to top, okay, it means bottom to top from here to here, okay. So we can write here from bottom to top from this type. Decimal number, this is binary, we already convert it. We repeat my answer. So we always divided by 2 and repeatedly and write down the remainders. Then we read the remainders in reverse order. It means from bottom to top we write, not from top to bottom, that is mistake, okay. So we take another example that is different from question A and B. This is decimal fraction to binary conversion. Means there is, this is a integer part, this is a decimal fractional part. Okay. So first of all, we take integer part. So we take integer part. Means we take 17. This is our 17. So we divided by 2. So 2 8 to the 16, remainders 1, we write down here. So 4 to the 8, so we write, there is no any remainder, so there is 0, so we write down here 0, uh, like this much. And then after we write down from 1 1 right here, then after 1 0 0 right here. So there, like this, we take another part, means fractional part, we take another fractional part. So fractional part is 0 5.570. This means we are similar. So we in integer part we are divided by 2 And in fractional part, we are multiply by 2. 0.57 into 2 multiply, you can calculate it 1.144. Integer part we put here 1, part make it 0 point something, okay, 1.44 into 2, 0.288. We write this 0 in here, means here, okay. So then after 0.228 into 2 is equal to 0.5760. So 0.57 into 2, 1.152. We 0, we make this fractional part in 0.152 into 0.304. We put here 0, okay. So in this way, we write from top to bottom. In integer part, we write from bottom to top, it means reverse order. We write from here in top to bottom, so 1 0 1 1 0. In 17.572 base 10 is equal to 1 0 0 0. It writes down from integer part, we take from reverse order 1 0 0 1. Then after we write from fractional part 0.10010. We write down from top to bottom. We do another example, 568.568. This is a integer part 568. So we divide it by 2. Okay, like similarly above the example, then after we can write from reverse order and repeatedly we divide it by, and then after we write down from reverse order, means bottom to top, we write there our answers. So then after we take from fractional part we make it 0.568. So into 2 we are multiply fractional part, we multiply, and integer part we are divided by 2. Then after this is our, we put 1 in from right here. Then after it make 1.136 into 2, 0.27. We put 0 from top to bottom. Then after at last 56.56 is equal to 1000101 0.1001001 base 2. This is our answer. Our next conversion is decimal to octal conversion. Convert decimal to octal conversion, we understand our theory, then after we do our example. To convert decimal to octal, divide the number by 8 repeatedly and write the remainders, then reverse the order of remainder to get the octal equivalent. Then after example, we are clearly understand how to convert decimal to octal conversion. First of all, I have one example, that is 445 base 10 is equal to what? It means what is the conversion of 445? So first of all, 8 divided by something numbers means 445. We write down from bottom to top. It means reverse order. Hence 445 base 10 is equal to 665. It means it has base 6655 is the conversion of 445 base 10. And integer part and fractional part of octal number. When we have integer part and fractional part, first of all we take integer part. It means integer part we are divided by 8, and in fractional part we are multiply by 2. First of all, when we multiply 8 into 15, there is a remainder 3. When we divide it, then after 8 into 1 means 8, remainder is 7. So we have done from bottom to top. It means like is a reverse order. When we convert fractional part again, then after we are multiply by 8. 8 is equals to 5.9624. It's the result. Then after integer part we write down here, and then after by 8 is equal to 7.6992. When there is a integer part we write down from here. When another 6.99, again fractional part we are multiply by 8, then after we get 5.5936, and put integer part from here, and like this. When we, this is all of you understand, when we are in fractional part we do 5 or 6 step, then we are automatically stop in that 5 or 6 step. At last we have 1.3.7453, which has base 10 equals to 173.5753133, which has base 8 is the answer of the conversion of decimal to octal number. Our next conversion is decimal to hexadecimal number system. First of all, we understand theory. When we convert decimal to hexadecimal conversions, similar other conversion, divided the decimal number by 16. Use A to F for values 10 to 15. Read the remainder in reverse order to get the hexadecimal value. Like is the decimal to binary or decimal to octal. But there is a difference is divided by 16 and in fractional part multiplied by 16. So we have 943 base 10 equals to what? First of all, by 16. So something 16 divided by 58 is equals to F. Remainder is 15. It means it is a 15 means F. When we divided by 943, which has base 10 equals to 3AF version of 943. Again repeat my answer and questions. We have a questions 943 which has base 10 equals to what? It gives the question, and then after when we see that type of question, we divide it by 16. Okay, there is a reminders we put from bottom to top. Okay, then after we have answer is 943 base 10 equals to 3A5 equal to 16. When we have both integer part and fractional part, first we take integer part, then after we take fractional part. First of all, we take integer part. Okay, integer part we divided by 16 and put the reminders and bottom to top, and fractional part we are multiply by 16 and into 16, then integer part we are put from here and again fractional part into 16, value from top to bottom, and hence 4.455.728 base 10 equals to C7.BA5E3 base 16 is the answer. We have another conversion, binary to decimal number system conversion. First of all, we understand theory. Each binary digit represent a power of 2. Multiply is bit by 2. Rise to its position from right to left and sum the result. Example, that is our example. When we have binary number to convert into decimal, we are multiply by 2 and rise the power from right to left. So 0, 1, 2, 3, 4, 5. So all these are multiply answer. When we have integer part and fractional part, when integer part plus fractional part we rise the value from right to left and sum the result, and then after in fractional part we rise the from left to right and rise the power from like this, you are multiply and get the like this result. That is our conversion from binary to decimal number conversions. Then after we have another conversion, that is octal to decimal number system conversion. Like similar as like as a binary to decimal number system, but different is that into 8 and rise the power from right to left. Okay, like this, right to left. Okay, like this, and multiply. Then after we get that similar that result. When we have both integer part and fractional part, also there is a difference. So we see another example and clear your doubt. Okay, so we have 7 3 base 10 is equal to what? It give like this. Write down solution, then after there like this and multiply by 8 and rise the power from right to left. Then after calculate and get that similar to the result like this. these values coming from between number 0 to 9, between 0 to 9. So we take another example, both combination of both integer value and fractional value. Solution, and then after, when we have integer part, we raise the power from right to left, and in fractional part, we raise the value from left to right, like this. Then after, calculate by calculating your numericals and gets the value like this. You must be careful that when your result come from value between from 0 to 9, your answer should be correct. Let's start our another conversion, hexadecimal to decimal number system conversion. First of all, that is similar to like is binary to decimal number system and octal to decimal number system. First of all, that difference is that it is multiplied by 16 and raise the power from right to left. So get the result like this. Integer part and fractional part, it's also similar like as other conversion. It means like as binary to decimal number conversion, octal to decimal number conversion in both integer part and fractional part. So have integer part into 16 into multiply by 16 and raise the power from right to left. And when we have fractional part, we write down multiply by 16 and raise the power from left to right and multiply it, and multiply then we result like this. Our answer must be correct when our result is between 0 to 9, so our result must be correct. Another conversion is binary to octal number system conversion. So that is simple conversion. When we have binary digit, means binary digit convert into octals. So binary to octal conversion, we understand that one thing is that when we write down from right to left, it means there is difficult. When we are write down from like this, like this, like this, like this, otherwise there is, we make three digits, okay, otherwise there is mistake, okay. So always we make three digit combination from right to left. Then after we get octal equivalent. That means our answer must be correct. So we write down from like this. This is our octal conversion. This is our octal equivalent, and write down the like this. We look at our rough. When we have 4, 1, 2, 4, 6, 8, 16, 32, like this. Similarly, three digits, so we write down like this and we get the results, okay. So when we have integer part and fractional part, we write down like this. Integer part like this, from where, right to left. In fractional part, we write down from left to right, and there is absent of three digits, we add it, add 0, okay, like this. There is a one, there is a we, okay, that is a octal equivalent, and that is a binary is converted into octal conversion. You must be clear that one thing is that when there is no three digits combination, you must be make it three digits combination, add zeros. In integer part, you add zeros at last in right to left. In fractional part, you add 0 from left to right, means it in last sequence you add zeros from. Look at my example here. There is a three bit diseases, okay. There is a three, there is a three, there is a three, and there is a three, and but there is a one only. I add two zeros, so that is a three digits combination. So all of you understood my answers like this. You can write and get your final result. Okay. Then after we convert octal to binary number system conversion is our another conversions. How to convert octal to binary number system conversion. First of all, we take an example like this. We have 3 bits 736 which has base 8 and what means we find 2 base 2 means binary number system. So we write down for the solution, then after octal write down octal number and like this and number or equivalent. Okay, then like this and it easy to convert octal to binary number system conversion. First of all, write down octal number like this and then after binary equivalent means 7. What is the octal number of 7 binary equivalent is 177 and 3 goes 011 and 6100 like this. Then after you write down your answer. Integer and fractional part we write down like this. First of all, write down octal numbers, then after binary equivalent and get the answer easily. It is easy. It is among other conversion. So we have another conversion is binary to hexadecimal number system conversion. First of all, we take an example and clear our questions. So when we have question like this, then after we take 4-digit combination. In octal, we take 3-digit combination. You already know that. First in hexadecimal, we take 4-digit combination. So when we take 4-digit combination, we take from left like this. 4 digits, okay? 4 digits. When there is no any 4 digits, we make it 4 digits. Okay? We add zeros. 4 digit combination. There is no any added zeros and hexadecimal number then get in like this. Another example that both combination of integer and fractional part. Integer we make 4 digits. In fractional part we make it 4 digits. There is absent of digits. We make it 4 digits. Look at my example. That is a 4 digits. That is a 3 digits only. We make it 8. We make it 4 digits and 8 zeros here. In fractional part there is a here 4 digits, but there is 3. We make it 4 digits and 8 zeros like this, and we take the hexadecimal conversion or this is a hexadecimal equivalent. Another conversion is hexadecimal to binary number system conversion. So we take an example. First of all, I write the hexadecimal number A3 and its binary equivalent is write down. Then after that easily you can look here. You can when we in octal number conversion we take for 3 digits. In hexadecimal we take 4 digits. So we take 1 2 4 8. Another conversion is both integer part and fractional part. We have both integer and fractional part. And when we have fractional part, first of all hexadecimal number write down and its binary equivalent. Then after that is your answer. Easily find your answer. Then after another conversion is octal to hexadecimal, and we have one example. That one example is number. So what is the what is the binary of 4? So I write down here. Then after 5 binary equivalent is that 1 and is that we make when we have octal number we make it 3 digit. Okay, When we have hexadecimal, we make it 4 digits. It's a simple, okay? So again, we make this this result convert into hexadecimal number. We make it 4 digits. So then we get hexadecimal number. When we are convert into hexadecimal, we make it 4 digits combination. So I get like this. So this is our answer. When we convert octal to hexadecimal, first of all we convert binary, then after we convert that binary convert into hexadecimal. When we have integer and fractional part, first of all, similar like as a above example, first of all we take octal into binary. First of all we convert into binary, octal convert into binary, and then after again we convert binary value into hexadecimal. We take 4 digit combination, and then after we have another conversion, that is hexadecimal to octal conversion. First of all we take an example and clear our doubt, okay? When we have an example to convert hexadecimal to octal, we write down hexadecimal to binary. When we convert hexadecimal to octal, first of all we convert hexadecimal to binary. Means hexadecimal means we have 4 digits. We write down 4 digits, that is binary value. Then after again we convert that binary into octal. Octal means we take 3 digits like this. You can also write down like this, okay? Then after, when we have both integer part and fractional part, first of all we convert hexadecimal to binary number, and then after again we convert binary into octal number in pure, means 3 digit. We get our answer easily. Today is this much. So if you like my video, please like, share, subscribe and my YouTube channel. Thanks for watching.